Good morning, Mr. Nico and Mrs. Sajani. In this presentation, we will talk about database-based software management data for solving input issues in POSYANDU. This is the overview. For the first one is introduction. The main problem in the topic is the workers who struggle with data input. This can happen because the method of data entry is outdated, where they have to physically go to the POSYANDU and write on paper, which can result in illegible handwriting for the POSYANDU staff. Another issue that can arise is the difficulty of using the application by the workers, or even problems with messy data on children at the POSYANDU due to the large amount of data, leading to data errors. To address all of above issues, an application will be developed to solve these problems by using a centralized and controlled database. The second one is literature review. The first literature review is about the integrated help posts face several challenges, such as the inability of parents and infants to physically attend the POSYANDU or other limitations that prevent offline interaction. The second literature, we get implementing a database system. The Puskas can easily manage and organize POSYANDU data, including generating reports on infant data and nutritional status in a systematic manner. The third literature, we get database system in multiple devices like mobile and web. The fifth literature, we get POSYANDU faces several issues such as data loss and data input errors. A database-driven application serves as a solution to these problems, and this is the example.
Hello everyone, my name is Hansel Kushaninui, and today I will tell you about my research. Similarly, at POSYANDU Dahlia, manual input resulted in numerous errors, leading to inefficiency on data management. This application not only assists with data input, but also how parents monitor their children's nutrition, making it easier to track and their nutritional status. The first method is simple additive weighting, or we call it SAW method. The Z-score was calculated individually for each child's data, and classification of nutritional status is determined based on the calculated value. This method assists in assessing and determining the nutritional food and status of infants based on their data within the POSYANDU application definition. Okay. So, the user has utilized an application provided by the Department of Health and to monitor the nutrition of toddlers in their work area. The application, known as the Dinkus, is accessible in managing nutrition data and gaining motivation for the work on the health post. This suggests incorporating AI assistance would enhance this application. The research method. So we use system development life cycle. We use SDLC prototyping approach with extreme prototyping type. We create designs using Figma and try to implement them with HTML and CSS. We already have clear UI UX concept in this application. POSYANDU still use paper. In some of POSYANDU still use paper to write data manually. The system flow in POSYANDU. First, POSYANDU staff arrive in POSYANDU. POSYANDU staff will take attendance of the patient with form. Then POSYANDU staff give form into the infant that want to check up. Next step, POSYANDU staff will check toddler's weight and height, and will write it in the paper at the POSYANDU square book. POSYANDU staff give vitamin or immunization for those infants. POSYANDU staff write result in the POSYANDU square book. Finally, POSYANDU staff make a report. And in our system, for POSYANDU staff will input at our website, so it's integrated with the database. So it will be easier to POSYANDU staff to input data without worry about mistake in input data or losing paper. Patient log in the website, then get their number for check up their infant. After that, POSYANDU staff input infant's data and their immunization. This system also notifies their parent to check up their infant. This use case diagram for our project in the stakeholder, infant's parent, and POSYANDU staff. The first activity is login, and the activity is done by two stakeholders. Input data and validation is done by POSYANDU staff. Infant's parent will get notification, do infant check up, and infant get vitamin or the immunization. So this is our ERD. In this following ERD, staff POSYANDU has many-to-many relationship with infant's parent. Infant's parent has one-to-many relationship with infant because one parent can have multiple infants. Infant's parent has one-to-many relationship with checkup detail because one parent can have multiple checkup details for their child. Checkup header is one-to-many relationship with the checkup detail because immunization has a many-to-many relationship with checkup header because there are many types of disease or immunization in the checkup header. Vitamins have a similar relationship to immunization.
Hello, my name is Advan Lansuswa. Here I will explain about the design and analysis. For the prototype in this application, we use Figma. The first is the login display. If the users doesn't have account yet, so the users can register first. Here we have three menus such as total data, officer data, and a summary. For the first menu, this is a total data display which consists of several tables such as child ID, name, age, weight, height, immunization status, checkup status, and data changes. Here there are several toddlers who haven't yet been immunized, where there is an icon for data that has not been immunized, like this one. Okay. If we press the icon, the notification will appear regarding the status of the vaccine. Then, next to the trash can, this one, is the edit data button. After we click that, we edit the data and we save it. For the bell image, it will show a notification display like a toddler who is still in the status of not being immunized or checking up. The previous red button or trash can is a button for deleting data. When we press, there will be a validation between yes and no. If the data has been deleted, the display will be like this. Okay. And after being deleted, there will be a notification like data with the name Lina has been deleted. If we want to add data, next to the search button is an add data button. After that, we fill in the data and then we click it to save it. Okay, this is the display when the data has been added. And a notification will appear data with the name Lina has been added. And this is the display of officer data. And the last is graphic display of the average height of toddlers list in the data from 1 year to 3 years, where the blue one is male and the orange one is female. Next is 8 golden rules. 1. Strive for consistency. We use the same color scheme as the base color blue, which prevents user from getting confused when identifying the page. 2. Cater to universal usability. In this section, we create easily recognizable icons that help users understand them. 3. Offers informative feedback. We provide notification that responds by changing the color of the icons, and pop-up notifications appear to ensure that users understand the application's response. 4. Design dialogues to yield closure. During the loading process, a loading logo will be displayed, indicating to the user that the application is currently in progress. 5. Prevent errors. To avoid accidental clicks on the delayed icon, we provide validation asking whether the data should be delayed. If there are any input errors, users can perform edits, ensuring that users' errors are minimized. 6. Permit easy reversal of actions. Users can choose the regular menu options to go back or delete incorrectly entered data. 7. Support internal locus of control. We create a simple interface tailored to the user's needs using a simple design to ensure user satisfaction with this website. The last one is reduce short-term memory load. User inputted data will be stored in the system and can be searched for when needed by the user. Then, this is the evaluation that we got from the interview results. And the last is conclusions. The nutritional data applications that we create aims to help improve the collection of data toddlers so that the information can be processed and analyzed effectively to improve the nutrition of toddlers in Indonesia. Based on various studies in interviews, we get information about the current websites being used and the needs of the users. Users require a website or application with a user-friendly interface, as many of them are elderly and need a simple design that is easy to understand. During the literature review, we found numerous design ideas that could be implemented, as well as different approaches to application development and their various forms. In the end, we create a community health center data collections application with a simple design that is easy for users to understand. We utilize a dataset for data storage. The priorities features focus on data collection, particularly toddler information, with additional features such as personal data and notifications for reminders or indications of information conveyed through our website. In the toddler data section, we have multiple data attributes following for a larger number of data samples to be processed. We also incorporate functionality to add, delete, and modify data within a dataset. That's all the results of presentation from group 5. Thank you.